All right, great. So let's get started with our webinar today. Hello, everyone. I hope you're all keeping safe with whichever part of the world you are in. Good morning, good afternoon, and evening to you. I'm Abhishek Mehta, Director of Sales Engineering at TigerGraph, and I'm going to be your host. With me today is Rob Houghton, who's Senior Sales Engineer at TigerGraph, and we will be taking you through a hands-on exercise on TigerGraph Cloud, giving you a use case understanding of financial industry, and we will be building this workshop out together. Next slide, please. All right. So today, what we will be doing is introducing you to a simple graph use case. We will be going over TigerGraph Cloud, a hands-on exercise. You will be So Rob will be walking you through how to set up a TigerGraph Cloud and give you a brief overview of our advantages and architecture. We will be creating a simple use case, as I was mentioning earlier. We will go through a deep link analytics use case, which will be coming out of a starter kit, which we will be spanning out, and some visual query example, and also RESTful API access. With that, what I'm going to do is I'm going to pass it on to Rob, who will be walking you through why TigerGraph. Rob, I'm not sure if you're muted. If you can please unmute yourself.
All right, thank you. I thought I had already done that. Sorry about that. First of all, let's demystify graph a bit by explaining it in context of relational databases. If you're like me, you've been working with relational databases over 20 years, and the concept of graph seems almost like a mythical creature that does magical things like find complex relationships between entities in your data. When we typically represent a relational database, we do so with a kind of terminology shown in the upper left of this slide, with tables in second or third normal form and relationships clearly lined out. You see the arrows indicating the cardinality of the relationship, which is typically one to many. Relational databases have served us well, of course, allowing us to store data on a variety of devices for a variety of applications. But logically, what goes through everybody's mind at this point is, what do I have to do to get my data into a graph database? That's really beyond what I have time to do right now. Pretty logical question. If you think that you have to restructure all your data differently going into graph than into a relational database, it sounds like a pretty big task. Graph will fit into your environment and power your advanced analytics to let you do things like fraud detection, next best action, and recommendations. And our customers are sourcing it from a variety of sources, like BI tools to just RDBMSs, from search engines, Hadoop, just raw data files, and machine learning tools like Python. With Graph 1.0 and 2.0, there are challenges taking the solution to the scale of big data. To enable powerful real-time applications like fraud detection and recommendation engines, the data must be able to be ingested and included in deep queries immediately. Now, when we join all these data sets together, you typically face challenges that these sources are, because they're in different formats. So joining them together can be a challenge. And then there are issues related to security. And of course, they're probably named differently. TigerGraph is the only graph database that can scale as an MPP solution, massively parallel processing solution, and can join all of these data sets at a huge scale, connecting them together, performing at speeds that can give you an advantage of not only solving your one particular use case, but building an enterprise-wide knowledge graph, taking care of all the security, which include your internal policies, as well as policies related to regulatory requirements like HIPAA. Choosing the right graph database is important. And what I would say is that we will discuss the qualities of graph databases and what differentiates TigerGraph in just a few minutes during our hands-on workshop. One question or comment that we often get is, my data is not in graph format, so we're not really ready to use graph technology now. Graph will fit into your environment and empower your advanced analytics to let you do things like fraud detection, skip one. Let's take a look at that relational schema. If you were like me, you recognize this type of view immediately. We're going to use this data throughout the workshop today in the exercises that we do together. It's a pretty simple schema. What you're seeing here is a user joining to a transaction table. This means these tables will actually join together in a couple different ways, once for the sender of the transaction and once for the receiver. If I was trying to write a query against a relational database, I would need to alias the user table and treat senders and receivers completely separately. That would work okay for simple queries, but when you try to perform multiple hops with the queries, it gets very complex very quickly. We'll dig deeper into this concept in a few moments. A payment instrument can be something like a debit or credit card or a PayPal account. Transactions are performed using devices. They're stored in the device token table. A device is like a mobile phone or a computer or an ATM. And what you're seeing here is a many-to relationship between the user and device. The user can use many devices, and devices can be used by many users. Now let's talk about how this schema gets converted into a graph database. One of the first concerns, like I said, that we hear is that we don't have in-house experience converting our existing schemas and databases into graph. But what we at TigerGraph try to help folks like you understand is that graph does not require unique special skills like Hadoop did when companies started to roll out enterprise Hadoop clusters. Now, when you go into an advanced level of graph database design and you go into performance improvement and complex graph algorithms, it's good to have those skills. But as a beginner, it's as simple as converting an existing table into what we call a node or a vertex. And all the attributes from each of the tables can be passed directly onto these nodes. So we create 4 nodes. The joins and foreign key relationships between them are turned into what we call edges. Edges will typically have a verb or action associated with them, like a user sends a transaction, a user receives a transaction, a user uses a device or a payment instrument. So let's think about the challenges people face while doing complex ad hoc query analysis or deep link multi-hop analysis inside a relational database. What's going to be the biggest challenge is deep link multi-hop analytics and finding and exposing the hidden patterns inside your data sets. It's very difficult. It's not enough to have a pattern structure of just, so let's take a transaction. Let's say finding a transaction between Abi and me. At first glance, you can see that maybe with a query that we've never had any transactions with each other. But if we look at the people in between and see that we're transferring money between each other and maybe in some kind of money laundering scheme, you'd be detecting fraud. So you'd have to go into different devices and device IDs. So it depends on it's just about finding the path between these nodes via the edges. And you may have to go over and over again and loop between these tables. It might be 10 hops between particular users, for example. If I did a transaction with user 1, who did a transaction with user 2, and so on, and ultimately maybe user 10 did a transaction with Abi. So there's a link between me and Abi, but it's 10 hops away. This may also be the case where user 1 sends money to user 2 sends money to user 3, maybe a few more users in the path, and eventually money gets transferred back to user 1. That's could be a money laundering scheme. And when it comes to deep analytics like this, there are some challenges with relational databases, and this is what TigerGraph and graph databases help address. Okay, so we can see there are serious challenges there, and this is what a schema design would look like. So it's not just a UI, but there's a schema behind this, and we'll talk about what happens, and we'll kind of demonstrate a shortest path algorithm. So one hop from a particular user is we have all the information about that particular user, their email address and account and phone number and so forth. And user one would initiate a transaction. There's a direct path from user to transaction, and transactions are performed using a device. And a transaction goes from one account to another. And when it happens in a graph database like this, there is a path to be traversed. It's relatively simple to perform and do this kind of thing with a graph database, and it's really tough if you're looking at a typical relational database structure. So an account has a user. In this case, it's user two. User two has corresponding details, just like user one. He's got a phone number and is using devices, and there should be other payments over there. And we can see that actually user 101 is transacting with this particular user. So when you see a layout like this, navigating from user 1 to 101, for those who've studied any graph theory, you can see that these two linkages are really nothing but finding the shortest path algorithm between two users. It's thousands of times faster to do this in a graph than in a relational database, not to mention exponentially easier to find and expose patterns like this in TigerGraph. Imagine doing the same kind of analysis, finding all the paths, getting to the user and the correlation using transactions, phone numbers, and so forth, using a relational database. Either you'd have to normalize the data set, to set yourself up for all these linkages, or you just have to keep on joining the tables recursively using views or aliases, and you quickly run into performance challenges if you try to operationalize this process. Okay, so what we want to do is start to get hands-on, and we want you to go to the URL that's listed there, tgcloud.io. You can actually go to HTTPS, I believe, and create a TigerGraph account. So there are a few steps there. So go through those to sign up, to set up your free account. You'll see that you can log in, you can sign in with Google, or you can just create a user ID and password down below. So if you haven't done that, now's a good time to go ahead and do that. Let me just take for a minute and tell you a little bit about TigerGraph Cloud. It's our managed service, software as a solution. It's a pay-as-you-go solution for TigerGraph that does three main things. It gives you a very flexible and optimized environment to do graph analytics and graph algorithms. Second thing is we offer up about 20 different starter kits that will accelerate your ability to understand and get started and drive value from graph analytics. Third, it offers up a platform for investigation, discovery, proof of concept, and production environment to support whatever your graphical needs are. I mean, this can be your environment. So we make it pretty simple and easy to get started to help folks get on board and get ramped up to speed. You get a free account. It gives you access to the platform for a bit, and there's some rules associated with it because it's free. If it's not been active for a couple hours, we'll shut it down. And if you don't use it for a week, we'll actually go through and clean it up. All right, so hopefully some of you have gotten to the point where you are actually in the solution. Let me go to and when you first get in, you might get to a screen that looks a little bit like this. This is the dashboard associated with TigerGraph Cloud. I'm already logged in. Eventually, you can put a credit card in if you want and actually buy time, and that's how you can use this on an ongoing production basis. But for just getting started, there's no cost. Okay, so let's start to let's go to the My Solutions tab. And you might not see anything here yet, probably do not, but up in the upper right, you can choose to create a solution. Now, when we go into this particular screen, what I recommend doing is choosing anti-fraud here. Now, we have so many starter kits now that it makes sense to have some buttons over here on the left to help actually support and to filter this particular list. So when you do that, just keep the TigerGraph version is 3.0.6, but choose fraud and money laundering detection. Okay, if there's 3 across there, it'll be the middle one. And then we click next. Now this screen is pretty simple, especially for today. Let's keep most of the defaults that are here. We'll keep AWS, TG free, North Virginia, 50 gigabytes is the size. And a partitioning factor, this is if you're going to create a larger instance of TigerGraph, you'd want to bump this up. But for now, we'll just keep it at 1. A replication the same way in a production environment, you want to have some replication going on. So we'll keep that at 1 as well. Then click next. And I've got some slides here for this too. We're there. So on this last one here, there's just a couple of things to take note of here. The name is just a default name, and the default is the date. The default tag is whatever starter kit you chose. It's going to have a tag associated with it. But the initial password here is important. This is different from your TG Cloud password. And Chrome may have actually pre-populated this in some cases with that password. Now this will default to TigerGraph, but we recommend putting something here. Think of this as kind of your database password in contrast to your TG Cloud password, which lets you into the environment. And subdomain is also important. I recommend making this something like your name. It has to be unique among everybody. So typically that's a good way to make it unique, is to put kind of your name there. And then for a description, we can call this workshop or something like that. And I didn't put my password. That TigerGraph. Let's see, you can toggle that on and off. And let's hit next. Okay, this just gives you a status of all the options that you've chosen. And so we will now hit submit. And this will actually take a few minutes to complete. You can see up here at the top that we have some pending tasks. And for me, I've got a couple of these that are being terminated, but the one that's being created right now is the top one. So you might have one pending task out there that it's creating your environment. While it's doing that, let's just talk a little bit about the characteristics of graph databases and some of the qualities that set TigerGraph apart from our competition. Number one, TigerGraph has almost single-handedly taken the industry to Graph 3.0. One key feature of Graph 3.0 is MPP parallelism for processing and the sharding of data for the graphs across different servers. This parallelism, this scalability enables TigerGraph to, number two, scale up for processing and out for data size in a way that's far superior to any other graph vendor. We've got lots of customers running terabytes of data in their graphs. The scalability lets us perform very complex deep link analytics that go over 12 hops for some of our customers. Number four, you'll learn more about GSQL as we go through the workshop, but if you have any experience at all with SQL, you'll be able to read GSQL pretty much right away. Number five, we provide many pre-built and extensible graph algorithms out of the box via GitHub, in addition to the getting started kits that we have that you chose when you started to create your environment. Number 6, multi-graph. It basically allows you for multiple views of your graph, which are made available with the standard RBAC security model. So you can have lots of overlapping types of data within your environment. We can go into this a little bit more detail later on, but it makes it a very powerful thing in where you can really minimize the redundant copies of data within your graph. GraphStudio, we will get to know this pretty well today. It's a nice tool that you'll get hands-on with right away, where you can define, load, explore, and write queries using GSQL. We've got a superior data compression engine. We've got machine learning capabilities to generate the deep link multi-hop features in real time for massive data sets to feed into other machine learning solutions. And finally, to do any real-time applications like fraud detection, next best action, and recommendation engines, you have to have OLTP capabilities, which means ACID compliance is important. So for example, in an MPP TigerGraph environment with multiple shards of data spread across multiple servers, an update transaction is not considered complete until all shards are appropriately updated. That's just one example of ACID compliance, and we could talk more in detail about that later if you want to. So with that, I want to hand things over to Abi, and he's going to take you through the hands-on part of the solution.
Great. Thank you, Rob. Now, if you please stop sharing your screen, I can share it from my side. Thank you. All right, everybody. I guess if you have questions, please use the Q&A section. You can also use the chat, but we will prefer for you to use the Q&A section. That will be wonderful. And if you can also message in a Q&A or a chat that are you ready to get started with a simple use case, that would also help us. Now, I'm assuming that some of you are able to create TigerGraph account and you are able to follow all the instructions which Rob was giving you how to set up the system. But in the meantime, what I will do is I'll just to make sure that we are all on the same page, I'm going to give you a walkthrough of what was done. A little bit of view here that once you log into TigerGraph Cloud, you are seeing your dashboard. As you can see, I have a lot of applications over here. You may or you may not have anything set up yet right now. So what Rob did was he took you through a create solution. We went to the create solution side of it. Sorry, give me a minute, please. Here we go. Create solution on the top. You picked up the one which you need, and you are seeing all these new starter kits and kind of step-by-step process to take you through. Now, why I am doing this again is, folks, that a few hours back, a new patch went into TigerGraph Cloud, and we released this step-by-step, getting up to speed with TigerGraph. So that's why you're seeing it for the first time, and you didn't see when Rob was doing it, because this just happened right now, and I was informed. Well, this is always a good thing. And if you're seeing a little bit different from Rob's screen, that was the reason. The patch happened only an hour back. Now, what we did was we started this particular use case. We started the financial services use case, which you were able to see here, fraud and money laundering. We used that. We went in. We picked up the AWS servers and all those details. And we put the Northern California 50 gigabytes, did the next, and set up all the details. Once you did, set up your password, which is, as Rob was saying, is your database password. You went in, clicked the next, and that is when your whole dashboard was set up and you were able to see this application. Now, since you are on it, thank you for confirming that you have this up and running. Wonderful. I answered that line. Let me remove the question. Now, you will be seeing this application most probably with the name anti-money laundering. So what we're going to do is that if you look at this section on the application side, you are seeing GraphStudio. And you're going to click on GraphStudio to take you to the Visual SDK of TigerGraph. And I clicked on it, and now you are in GraphStudio. If you are not in GraphStudio, the possibility is that you are on the login screen. And if you have set up use the default password, whatever you have set for your database, you should be able to use that and get into the system. For me, the default username and password was TigerGraph. That's why I came in seamlessly without any challenge. And once you are in it, you will be able to get through and use TigerGraph. All right, so if you are on the GraphStudio screen, first thing to know here is that you can design your schema, you can map your data, right? The data comes from outside. You can load it, explore it, build your graph patterns, and write some specific queries. So what has happened is that when you have started this toolkit came in by default. So on the left-hand side, you need to drop down. This is called the multi-graph space, and you're going to pick up anti-fraud. And once you go into the design schema, you will be able to see the use case which Rob was referring to earlier on your screen in the Rdbms size. But I'm not going to take you into this use case directly. First, we are going to build a very simple use case based on all the capabilities which TigerGraph has of creation of a vertex, creation of edges, how to load simple data, all that kind of work, we can do it on the side. So let's do here. On the left-hand side, I'm going to create a graph, and I'm going to name it fraud. Let's say I'm just naming it fraud 4. So this is the new graph I'm creating. Please do not choose any vertex type at this stage. We are just creating something called fraud 4. It's a totally new graph database, different from your toolkit, because I wanted to give you an experience of how the entities and all the edges and the vertices are created inside Graph. So I'm going a little bit quicker than some of you may have to follow, but you are going to get the recording of this screen, all of this session. You will also get our slides. You will also get the exercises which we are going to do today. So bear with us. Feel free to ask questions. Rob is there to answer. And I am going to create a vertex type. Look, I clicked on the plus sign on the top, and I'm creating a vertex named user. Okay, I'm just calling it user. And on this user, I'm going to create an attribute. See, this is no different from how you would do your Rdbms. Okay, I'm creating mobile number, making it a string. You can decide whether it's indexable or not. Next thing I'm creating is, let's say, trust score. I'm making it a float, and I'm just using something concat. I wanted to show you concatenation capability inside our system. I'm calling it string. So this is how you create a vertex and its edges. I'm creating another vertex named transaction. And this transaction has a timestamp. Let's make it a date time. And I'm going to make the next one as, let's say, amount. And this amount is a float type. And here goes another vertex in the system. So now you have two different edges, two different vertices. This is how you create your schema inside the system. Next step is to connect them. So I'm going to connect user with transaction. You see, I clicked on one, I clicked on another one. There are directionality, which direction the information flows. There are reverse edges. These are a deeper concept. We can cover it sometime later. But right now, let's make it a directed edge. And I'm going to call it, let's say, user does transaction. So there is a question, what username password should you use when I click on the TigerGraph Studio? Now the username should be TigerGraph, and the password should be the one which you have set on the previous screen. When you were setting up the system, there is a possibility that you didn't set anything. So you try the TG Cloud password just to see that if the system picked that by default. So here we go. We do user does transaction. And the next one, we will say, okay, user receives a transaction. That's it. So this is our very basic schema. User does a transaction, user receive a transaction. One I have made directional, other one I haven't. Or I can make it this one directed too. I can go in and edit it, and it's also directed. So all this information is editable. You can go into the system, decide on what kind of colors you need. You can always change the look and feel of your vertices over here. You can select default icons. You can also upload your icons, but I'm not going to change anything by default. And I'm going to publish this schema. Now, this is very important aspect, folks. You need to publish the schema so this information to be persisted. Remember, we are doing a subgraph. We are not editing the original schema what we created, which came built with the graph. That is called anti-fraud. So we are building something separately just to show you how these things can be done basically inside our system. Once you have done, you have the schema ready, the next stage is mapping data to the graph. Mapping data stages involve loading the files, whether they are coming from your S3, CSV files, connector frameworks, TigerGraph, all those capabilities. But over here, we are going to use the files which came default with this use case. So I'm clicking on this plus button, and I am picking up client CSV. As you can see, this is not well indentated yet, right? Because we need to tell the system how this has to be parsed. So I'm choosing the first line as header, and the delimiter as /t. It's a tab delimited file. Once I have done it, I'm going to add it to the system. I added the client.csv. Next stage, I'm going in, getting the transaction data into the system. Again, it has header /t add. Now we have added 2 data sets in this system, which will be loaded inside Graph database. As Rob was telling you earlier, we don't have to do anything special to massage your data to bring inside the Graph database. You know, your data set, the way they are right now, can be very well utilized to load inside the Graph. We can just turn a table into a node. An advanced level schema design and advanced level efficiencies you can bring in later. So that's not for the learners. Now I'm going to load this client data into the user vertex. So I picked up these map data files, these arrows on the top. I clicked on CSV file, you load it into the user, and I'm telling the system, here is a sample set coming from the CSV file, that this user ID is the unique ID in the user set. Here is my trust score. Here is my mobile number, which we don't have for the first user. And now let's use a token function over here. We are going to use a concatenate method, which is built-in ETL function, concatenate. And I'm saying, why don't you concatenate the user ID with the mobile number and store it in a separate field? So as you can see, we are building up the very basic ETL capabilities out of the system. We have scripting capabilities, and those scripting capabilities can be used to create much more smarter interlinked, data loading pipelines. So now let's go into the transactions. I'm going to load transaction into the transaction table. UUID is missed. We can, we can also use auto mapping feature if the names are same, but unfortunately not in this case. So here is the requested at. I'm connecting to the timestamp, and the amount I'm putting into the amount table. Now, next stage is that you are going to create the edge between these 2 data sets, right? So if I look into our transactions table again, a CSV file again, it is telling us who's the receiver and who's the sender. So the data of interlinkages and edge creation, technically your foreign key, has to come from the transaction side of it. So I'm going to only map 1 transaction here for sake of our, just for very, very basic connection building. I'll not map the second one in interest of time. And here we are saying that this transaction is done because user does transaction. So the client here is the user here on the top. So this is the foreign key relationship we are building. Let me map another one too. So I'm again clicking on transaction. I'm going to the user received transaction. And over here, I'm telling the same transaction is being received by a different user. So this is how you do the very basic mapping exercise inside TigerGraph, and let us publish this mapping. And okay, the mapping is published. And the next stage is load this data inside the system. Now the mapping is done. Let's run our loading exercise. TigerGraph is actually a distributed graph database. So that means that you can load data much more faster and quickly. It's just not that you can process it. You can load the data also at a very high speed. Our average speeds are like millions of rows per second, right? I mean, it's a very fast system to load data, especially from CSV files. And all the links and interconnections are being created. And as you can see, we have already finished loading 2 million vertices, 4 million edges, almost 1 million transactions, and lots of other details inside the system. Next stage is exploration of the data set. So don't worry if you're not able to follow this, that is okay. This is also to show you the capabilities. We will show you much more detail inside the starter kit when I get into it next. So let's look at one of the aspects which Rob was showing you earlier. Let's first start doing the exploration of this data. There are lots of capabilities here. You can edit the data. There are UI possibilities. You can write rules to have some nodes based on filter criteria. You can set up filter criteria to change the radius of these circles, color of these circles. Various different kind of settings can be done to show, let's say, mobile number or trust scores right on the top of here on the screen. But one thing for anybody who is new to the graph, sure. So the question is, some of you guys are behind. Now, that is okay. That is okay. The purpose of this exercise is actually to show you the capabilities. But if you want me to wait for a few minutes, I can definitely do that. We have created a basic schema. We have mapped the data. I created a basic schema. We have mapped the data in the mapping exercise. That is okay. If you did not follow this, I will show you much more smarter mapping exercise later. We loaded the data inside the system, and now we are exploring it. Exploration goes like this. This is where you will start seeing the differences between Rdbms and a graph database. So this is not just a pretty visualization. This is just not a pretty visualization, right? There is a model behind it. This user did a transaction. It takes two to do a transaction. There comes another user behind it who might be having his own transactions. And these transactions are conducted between the other users. So all of you who are new to Graph may have tendency to confuse this with just pretty UI. That's not the idea. Let's see what it does for you, which other solutions cannot. Now, in the system, you can ask the linkage between one transaction and a user, random users, right? You just can say, find me how these two entities are interlinked. This could be a user, this could be a transaction, this could be a product you're trying to sell, or you're trying to create a recommendation system on. This may be a fraud analytics case where you have a SAR, suspicious activity report, and you want to see how the various different parties are correlated with this. This could be a supply chain entity and of your vendors, and you want to see what is this vendor's address and how one vendor is connected to another vendor. So it could be anything over here. The power of the system lies in your ability and Graph's ability to find the correlations between the data set by default. Now here I go, I tell the system, find me the path between these two entities, and system goes in and figures it out by itself over millions of entities, millions of vertices inside your system, and very minimal hardware what we have used over here, probably 4-core machine behind the scenes. It went ahead and it found this correlation between you without writing any GSQL or any other query. This is the shortest path algorithm which system is able to figure out for you by itself and find this correlation, expose this hidden pattern inside the data set. Next exercise over here will be our query writing capability. So what you saw right now was a very basic example of how to traverse the graph data set. But that is not always the use case. You want to do something more concrete, something more smart, something more intelligent on your data set. So what I wanted to show you back into our sample exercises is that you have all the details of step-by-step what we did. You will get the video recording of this, and you may have option of downloading the separate files also if you want to do it, or you can use the default data which is loaded into the system. You know the mapping exercise, and here are the basic set of queries which you can fire on our system to get to the results what you may need. These are, anybody with a programming background may not take long enough to find out how these queries work. So there are 8 basic queries. The one is about navigation of how the data is navigated, the one which I was showing you on the exploration side. There are others with the various different clauses, right? You can see over here where clauses, order by, and the third is about edge printing on the accumulation side. Accumulators are used over here. So these are various different exercise details about our programming language you can find on TG Cloud, and it's docs.tigergraph.com. where you can go in and get how to get started with TigerGraph, how to load it, how to use TigerGraph Cloud, how to use GSQL. So all those details are mentioned on our documentation sheet. And over here, I'm going to give you a very basic example of how to write a simple query. So over here, I'm just going to copy our first query, come into our write query mechanism, and I'm writing here my first query. Okay. And in this query, I'm just typing in all the details. I'm going to parameterize it. I'm picking up a vertex type user, and that is getting parameterized over here. I'm saying, okay, I'm giving you an input user, and for that user, what do you want to do is user does go through a particular user, which I'm giving you. From that user, start and select what this user does and what kind of transaction this user has done. So if you can see over here, user does transaction. I'm going to navigate this edge and print all the transaction this user has done. I'm saving this query. Now I need to find out what username I have to give. So you can go in here. We can pick up any random username. I will go back to our exploration of the queries. I'll say clean up everything on the screen, and let's pick a user. Okay. How about I pick a user? Is there a username user1? Okay, there is one. So I'm going to use user1. And print me all the user does transactions on it. And as you can see, all the transactions which this user has done have been printed over here. There are various different ways of various different ways in which you can write these queries. You can print edges, you can do aggregation, processing, graph algorithms, and a lot of different capabilities which our system has. You can perform all those. You can find more details about it in our documentation. So this is the very first basic query. And let's go back and see some other query. This query is about edge printing. So I'm going to copy.
Yeah, Abhi, I'm copying those into the chat, the queries, so folks can grab them from there if they want.
Wonderful. Thank you very much. I'm going to copy the second query. And what does the second query do is it's going to print these edges, what you have seen on the screen right now. So these are very basic queries, folks. We will just go into deep link analytics after giving you a picture of what is possible inside TigerGraph. Just to save time, I'm just copy pasting all the details. I'm starting with a user. And as you can see, my edge name is different. It's giving me a warning. I'm telling the system, find me all the users where the amount is more than $10. Right, so right now you can see there are 72, 62, there are a couple of tens. So I want to make sure that we just get the amount which is more than $10. And I'm just going to say, send them, then the limit is 2 results. Just show me the 2 results out of it. Again, the user 1, and you would see the results change. Now we only have 2 users over here, and one is 72. Another one is showing you the amount as number 12. Now, the output of TigerGraph can actually be utilized not just by this visual components. The output of this is for your integration into any downstream application using our JSON files. All this output can be accessed through the JSON files. All these queries turn into RESTful endpoints. So you can call them from, you can put securities on them. There's a token-based access and all those details in the system. And you can integrate with your Tableau's business intelligence tool, whatever you're utilizing, or your Python application. We have a full-fledged ecosystem to give you to connect your TigerGraph system with your Python notebooks. We got JDBC drivers. We got connectors for Spark. So that is all available in our open source community. So right now, folks, what we just did is that we have created the very basic queries inside our system. And you have seen how to design schema, map the data, load the data, explore it, and write a couple of queries. One thing to remember is the TigerGraph queries can be run in 2 different ways. One of that could be compiled mode, and one of them is interpreted mode. Right now, I'm running in interpreted mode, and those who are aware of compiler design would be able to tell you that if you run in a compiled mode, the query is going to be much more smarter and efficient. Well, not smarter, I would say efficient in terms of performance. So you have both the capabilities available inside TigerGraph. Now, let us switch to all of you. If you have not followed, that is okay. That is fine. If you're not able to catch up with me, let's go on the left-hand side, click on this drop-down list, and go to this first graph we have, anti-fraud. And this is where the main learning for today will begin. Okay, so I guess somebody posted comparison. Yes, we can do a lot of comparisons. We can discuss about it in detail, but again, third-party tools have different ways of comparing product, yes or no, so that may be fair, may not be fair on our computation. But if you are interested in knowing TigerGraph's comparison and differentiating factors, I'll suggest you to reach out to us from our website, or you can reach out to me at abi@tigergraph.com. All right, so all of you who are at this page can see the schema. You got a user. You can see this user has various different attributes. And these attributes are of different kinds. You can see over here, string, uint, floats, and all those details. Payment instrument is there. Use case has already been explained to you by Rob, so I will not spend time on it. And user can refer to another user. As a mapping exercise, which we did for a very simple application. Okay. Looks like the mapping of this data isn't being where it should be. Okay, so the data is loaded into the system already because I preloaded the data. And if you are in our system, you can just go in and see how much of the data is preloaded. Over here, as you can see, we have total vertices 4 million, total edges 7 million, payment instrument, device token, and all of this data is preloaded into our system. Now, if we explore this kind of data set, you see this is the real data. As I click on it, you can see many transactions this user has. All right, so folks, I think there is a little bit of challenge in this hands-on exercise. So what I'm going to do is I'm going to spin up one more server for me right now, so you will have a chance to catch up again. So as this is getting set up for me, let me very quickly walk you through a couple of other capabilities inside TigerGraph. So one of the features which TigerGraph brings for you is called multi-graph. As you can see, when we were doing this application, you saw a couple of different graphs which I have created. Right? That capability is unique to TigerGraph, and it's called multi-graph. So TigerGraph's multi-graph basically is a logical segregation of your data. The primary citizen inside TigerGraph is basically nodes and edges, or called vertices and edges. And as you have those vertices and edges, you can bring all of that data into your system, and you can draw logical graphs on top of it. What does that mean? Logical graphs on top of it. Let's say you have consumer department data, you have product department data, and you want the enterprise view of both of these data sets. But logically speaking, not everybody should be seeing credit card information on the customer side. So how would you hide that data from the product people? You will create multiple graphs out of the same nodes which you have, and you will leave out some of the edges and the vertices which you don't need, because the product department shouldn't see it. So you will create a couple of different graphs on top of the data set that you have, hiding data set from one view and making it available on the other side. And based on that, you can give different access rights to all the user sets that you have. You can give various different kind of roles to the different users who are on using these graphs to make sure that one department doesn't see other department. Somebody can fire query, somebody can create just administrative. Some may have an admin right to create users, other may manipulate the data. So you can have role-based access on the top of multi-graph, and they can also integrate with your LDAP services internally. Okay, so my system is ready. What I'm going to do is I am going to start another instance right now. So there is a question on license policy of the TigerGraph. I would suggest you reach out to us separately. A license policy of TigerGraph is available on our website anyway. You can go to docs for TigerGraph and search for the licenses, and you will find the information. And on the pricing policies, please reach out to us. The TigerGraph pricing policies is on the website itself, and you can use it. And you can make some calculations. But if you need to use the system, in much more serious way, I would suggest you to reach out to us from our website. Do you have an isolation feature on multi-graph to make sure the transaction on one graph does not affect the transaction affect the other graph using the same data? No, these are the logical segregation of data. If you have two graphs which are overlapping a transaction set and you make a transaction and change in one of them, it will be reflected onto others. So we are bringing the logical separation. We are not making the copies of the data. All right, so let's look at the schema again. Let's look at the mapping of the data again. Okay, wonderful. So as you can see, all this data is already mapped. It has much more details about how the users are interconnected, who's referring to whom. As soon as you spin up the anti-fraud use case, you will be finding all these details. And you can see the user and payment instrument, user is connected, how the edges are connected. I will suggest you to have a deeper look and also experiment with our filter criteria and also the inbuilt token functions inside the system. You can see concatenation and conversion of integer to string, also case flow statements, and it's all part of the system here. Now let's load this data, which is part of the starter kit. And I am going to load all this information, and this is going to be substantial. This will be much more bigger than the data set that we have used earlier. All right, so the data is going in, millions of vertices. Let's give it a little bit of time. All right, payment instruments are yet to come in, so I'll wait for a little bit more. Okay, so pending. Okay, these two files are pending. Let it go. Let us give it some more time. Okay, so as this is getting loaded, I will move on to the exploration of graph and give you much more deeper view of the data. Earlier, you saw user was only having transactions. Now this same user is having much more details, right? You saw. All right, so data, I guess, is still getting loaded. Let's give it some more time. Right, it is in. So you can see I have payment instrument over here. This payment instrument may be used by various different users, right? So there are many users who are now getting connected just by using this payment instrument. And these guys have their own details, right? As you can see, they have their own transactions, they have their own devices, they are being referred by another users. So as we explore this kind of data set, what you would find out is that finding the correlation when the data is structured in a graph format is much more easier. So the shortest distance algorithm, which we did earlier, I'm going to show it to you again. And now I am going to attach it with two different end users and say, okay, go ahead, find me the correlation between these user sets. Here we go. All right, here we go. Maybe I should make it a little bit cleaner. And I would say only one shorter spot. Here we go. That's much more easier to understand. Let's have a better view of this. So our user, which we gave as a starting point, did use the payment instrument used by another user who did a transaction with Mr. 13639. That did the transaction with in between user, and that did the transaction with our end user. So finding this kind of correlation on a regular RDBMS kind of style and putting in those Cartesian join is very expensive, very cost prohibitive. This is what we call as deep link analytics, exposing the hidden patterns inside your data set. So now let's take it to the next level. And you have lots of queries which are already pre-built inside the system. So if you are in the right query stage, I'm going to ask you to install all these queries. So if you see this button on the top, you can install all these queries. It's going to take a while because what's happening behind the scene that these queries are getting compiled, converted into a C++ code, getting compiled and being loaded inside the system. So this can take a while depending on how many queries you have. Since we have a lot of queries here, that gives it a few more minutes. And in the meantime, I can take you back to what we were discussing on the other side, or I can take a few questions. I'm done. Okay. So Rob, is there any question waiting in the chat channel which I can address at this time?
There was one about, is it possible to plug in a backend application to send a query to TigerGraph and get the results set back?
Oh yeah, absolutely. You probably would have seen the JSON output, which I was showing you on the screen. So that can be interlinked. You can fire the query on TigerGraph and you can use the JSON output to run it on your application. And if you're talking about sending in the data inside TigerGraph, you can use our TigerGraph connector. You can use our JDBC driver. There are loading jobs that can be performed offline and online. You saw me performing a loading job from GraphStudio. You can also perform loading job from RESTful APIs or using our JDBC drivers. So there are various ways possible to connect incoming system and outgoing data set with TigerGraph. Okay, let's see where we are with installation of the queries. Okay, it's going to take a little bit more time. In the meantime, I can show you our administrative capabilities. So TigerGraph administration, you can see how many machines you have in cluster. Of course, there are date bound. You can see all your stats. There are various different components inside TigerGraph graph processing engine. So all the query processing takes place in the processing engine side. When you have a distributed query to be executed, TigerGraph will break down your query into smaller subtasks, and they will be executed in parallel based on all the cores and the machines you have. If you have a distributed cluster, the queries will be executed, the sub part of the queries will be executed parallelly on that machine, and that is the responsibility on the various machines available, and that is the responsibility of graph processing engine. Graph storage engine on the other side is going to store the metadata information, going to store the internal ID to external ID conversions, and of course the data which will be persisted on the system. And this is ACID compliant, folks. So you have to remember that, right? Means when you are committing a transaction, a snapshot of your data is taken that is being acted upon just to make sure that there is no corruption of data so that all the ACID properties are kept in track. RESTful API, so you can see a lot of details on cluster monitoring. And of course, the details about your RESTful API, the queries that you fire, right? So you see these are the queries and how much CPU power to take, what is the timeout, what is the latency. So this is the administrative console. And the good part of TigerGraph is that you can also now do user management on-site TigerGraph. Right now, we just created a single user, which was administrative user. Now I'm creating another user. Let me remove this user. I'm adding a new user, Abi. Okay, very simple. And now this user can have various kind of roles on various different data sets with you, the graphs what you have inside the system. So let's make Abi a designer for anti-fraud graph, the graph that we just created. So when Abi logs in, he will only have access of a designer. And what is the access of a designer? So in our documentation, it's very clearly mentioned. These are the out-of-box roles you have: observer, query reader, writer, designer, global designer, administrator. And here are the possibilities what they can do. Somebody can drop a user, show a user. Of course, that is administrative task, so nobody else can create and drop a user. Similarly, all the details are available on our website if you want to learn more about creation of the user and administrative rights. And going back to giving access to a user on the graph, that's where the multi-graph capability comes in. On a fraud 3 use case, you see I haven't given Abi any access, and I can make Abi admin for this different graph. So inside a graph, that's our multi-graph capability. So if Abi logs back in, now I'm not Abi, so that's why you're seeing everything. He will be only seeing on the fraud 4 size the administrative capabilities, and for the anti-fraud use case, what you have on the top, he will not be able to modify any data. So that's user access right management. Let's see what our system is performing. Okay, we have installed all the queries. So let's do a multi-transaction use case. So what's happening here is that, let's say we are trying to do an anti-fraud pattern. A transaction comes in over millions of records, what we have, and it takes 2 to do a transaction. We understand that, and millions of records already in the system. We are aware of this. And the use case here is that if the user on the left-hand side and on the right-hand side, they have their own network of users whom they are transacting with and devices that they all are utilizing. What we want to do is that see if any of the left-hand side, right-hand side cluster of the users that we have are transacting among each other. I mean, this may lead to an anti-money laundering pattern. A transfers money to B, B to C, C to D, and D back to A. So how would we capture that? Maybe from bank account, or maybe just from devices, maybe just using the payment instrument. So this one is actually focused on the devices. As you know, millions of records in the system already. There is no caching involved. I'll show you the query in a minute. And I wanted to first amaze you with the speed at which how the system will perform. In such a small amount of hardware that we have over here, in a matter of milliseconds, this transaction has been traced. The user on the left-hand side and the right-hand side has been recognized and fetched. Their device payment instrument has been recognized. For those payment instruments, what other users have used those payment instruments, and their payment instruments have been recognized on the right-hand side, same done on the left-hand side, and as you can see, one transaction of $7 has been recognized in between them. All of this in a matter of milliseconds. All of this was done in such a short amount of time that this becomes a system which can really feed into your machine learning algorithms. Right? If you're doing feature extraction for your machine learning algorithms, you need such a fast system to have smarter features extracted. You can't run an overnight job on a Hadoop cluster or non-real-time Spark on your data set and wait for that process to finish. The biggest advantage of Graph, what it brings is that it can do these deep link multi-hop analytics, feature extraction, and investigative kind of jobs in a matter of milliseconds, which is not possible on the other side. The other aspect of the Graph is that when you structure your data inside Graph format, you can run Graph-specific algorithms, which are not available to your regular two-dimensional data size which you use for machine learning. For example, page ranking, how these users are feeding into each other. You can find the most effective user in your overall ecosystem who's transferring more money. Maybe that's a high net individual. Maybe that's a fraud ring. You can detect it anyway, right? And you can do community detection algorithms. And that too on a speed and scale, which wasn't available to you earlier. And that's where the Graph's value, TigerGraph's value lie for you. Let's look at this query very quickly. Here we go. As you can see, this is called GSQL. This is our programming language, which is very much like SQL. We saw a sample of it earlier when I was doing the simple exercise. Over here, we are starting with any transaction, which is actually given in. If you remember, I parameterized it. This transaction was given. And from those transactions, we find out who are the sender and the receiver. We find out the two users who are associated. For those users, we are finding all the devices and the payment instrument. Remember, I showed you the payment instrument in the middle. And for those payment instrument, we again find all the users and transactions of them. And one more level of user transaction, and joining all this data set together and see if there is a commonality in between them. So all this piece of code in such a huge data set was able to execute in a matter of milliseconds. There are many other possibilities, right? Means, let's say transferred amount. This query answers the question that a given user find out how much money has been transferred out from his connected users within a date range, right? If we are tracking something or doing analytics that Abi's average money transaction from his bank account is let's say X amount of dollars, and what about average of the people who are connected with him? Maybe he's transferring money which is more than his average. Maybe there is a standard deviation problem or challenge over here, or maybe there's an anomaly from his bank account. Maybe it's been hacked or any such kind of query. You want to do these calculations from the network of users who are transacting. So let me put a user ID here, and there is a start date and an end date. Here is a GSQL query written over here. All these queries, folks, are available to you. When you start up the starter kit, please go ahead and read it. Start from basics, and this could be your way into writing complex queries. Again, time-bound query for all the network, and you can see my network over here. This is the user I put in, all the payment instrument they have utilized. This is the network I formed, the guys using the same payment instruments. But the idea here is not the visualization. Idea here is the amount. And as you can see, the summation is $5,538 have been transferred between all the network of users, using the same payment instrument. So aggregation, summation, ordering, calculations, modification of data, edges, creation of new links between the data set, all can be done at a very high speed and pace with the graph databases. And again, this is a JSON output, integrated the way you would like. All right, with that in mind, is there anything else we can cover for you? Please keep your questions coming. I will be very happy to take last 10, 15 minutes and answer some of the questions for you. Otherwise, I will walk into another aspect of RESTful APIs. There are RESTful endpoints on TigerGraph, right? You can request tokens, you can get echoed information, you can see handshake signals to TigerGraph, you can get various different statistics, versions, schema, vertices. So these are all out of box from TigerGraph. You can look into our documentation side. Here are the details on our RESTful APIs. For token generation, then there are details about built-in endpoints in our system. These built-in endpoints can be server endpoints, system utilities, handshake, version details out of TigerGraph, and of course, modifying and accessing your data. You have graph names, you have various different kind of deletion of dataset capabilities, built-in endpoints, which are technically, some of them are your queries, data definition, managing and running your queries, pathfinding algorithms, and above all, what you want to see as graph algorithms. We have an open source GSQL graph algorithm library, which is available on GitHub, which have all these algorithms ready for you to utilize and work. All you need to do is copy the algorithm, paste it into your side, into your GSQL query, just change the parameter if you would like, and execute them. There is a question, what do you recommend as a dashboard to present the data? Answer would be that you can use anything. We have our own partner network, and there are like many different names on it. I would not like to call one out. So that is one possibility. If you're just doing a graph visualization, we have our own toolkits. We have partners who provide you toolkits for very specific purposes. For example, anti-money laundering use cases. We have toolkit which will do investigation, SAR, and alert generation, workflow of alert generation. How do you set up a rule-based engine? If amount of money transfer exceeds certain amount, alert will be generated, emails will be sent, and there are dashboarding capabilities which can be a drop and drop. And there are also geolocation-based capabilities in these kind of toolkits. Third way would be you using anything like your own Python notebooks, right? You can use pandas to visualize it in table format. You can export the data out of TigerGraph into Python. Another possibility is Tableau or any other BI tool. So it's all up to you. Let us know what do you want to use, and we should be able to connect. And the easiest answer is that if we don't have an out-of-box connector, it's always a JSON file that you can use. And there is another question there is a follow-up on my first question. Is it possible to send high-level query string that can be translated into GSQL and graph query? That is a wonderful question. In fact, we are moving towards, let me not disclose too much about it, where you can actually type in simple natural language kind of query. So we are working with one of our partners where somebody can type in a very simple natural language query, and that can be used to convert based on, of course, some NLP libraries that will be converted into GSQL specific query, and execution will be fine, and the execution will be done, and the answer will be sent back to a chat box. Could you talk a bit more about machine learning algorithm could utilize the results coming out of a graph query? Could you talk a bit more about how machine learning algorithms could utilize the results coming out of graph query? Yes, absolutely. So the one aspect of this is using GSQL queries or graph query in this case to extract features. I was showing you a multi-transaction use case, right, where I gave you a transaction and we said, is there a circle in it? Do the people on the left-hand side are transferring money to the people on the right-hand side of a transaction? So that could be very well be a feature extraction in this particular scenario. You might do another kind of feature extraction on a referral fraud. You might do a different kind of feature extraction on a recommendation system. There has been a scenario where we were trying to find out what about, what is the average, what is the possibility of a rideshare car driver getting the same ride within a week for the second time within a week, right? I mean, what is the probability of that? What is the probability of the same sales guy on a telecom shop selling a second fraudulent device which ended up being a fraud? So whether you are extracting a feature, whether it's about circle detection, exposing a hidden pattern, finding the correlation between the companies, which is the parent company, which is the child company, that is all possible. So one aspect of using in machine learning is definitely going to be about your feature extraction, whether it's for your training data set or it's for your testing data set or live data set what you're utilizing. So that is a big feature. On top of that, there is also these machine learning algorithms on the side, which can only run on graph algorithm, right? PageRank. Find me the most important merchants in a particular locality based on the density of the people who are going to those shops to buy. So yes, that is what you can do. Can you talk a bit? Okay, so I think I have answered most of the live questions. Now we are a little bit ahead of the schedule. So I would like to—
There's a few questions in the chat, Avi.
Oh, sure. Can you please read that for me?
Yeah, what is the NLP algorithm used for string comparison by TigerGraph is one.
Okay, so NLP algorithm, that's a very heavy loaded word, NLP algorithm for string comparison. I mean, we won't do string comparison using NLP. You know, there are various different ways you can utilize that. I mean, there are similarities on Jaccard similarities. There are min hashes, there are sim hashes. Whatever you would like, we can build inside TigerGraph. Secondly, whatever isn't there inside TigerGraph, we can utilize that. We can create a UDF, user-defined function, and we can build that algorithm. So simple string match to, you know, min hashes, sim hashes to Jaccard similarities, we can run all of them. All right, you said there was
there's
another
one.
question. Yeah.
Yeah, actually, it says simple question about generating output from TigerGraph into RNN. Please comment, what are the ways to go from your graph database to inputs for recurrent neural networks training?
So we have a webinar on that. I would suggest you to go through it. It will have much more detail than me giving you a very surface level answer. We can output in various different formats. You know, it could be the JSON you saw, CSV you saw, tabular formats are possible. And also, you know, there are various different ways you can generate. And also, there have been some work being done on the deep neural network side also. So I would skip that question as of now, but there is a webinar available. Please search through our website. Unfortunately, at this stage, I don't have an answer ready for you. All right, so we are a little bit ahead of time, folks. Please try out TigerGraph on tgcloud.io. Feel free to reach out to us on abi@tigergraph.com, and we will be able to answer you a lot of the questions. If there is no question coming in a minute, then we will close this session. And thank you all for so much. So thank you all for joining us that early today. All right, Rob, thank you very much for your time. Okay, there is, all right, thank you. Thank you for the present, you know, acknowledging that. Great, thank you, everybody. So we'll be closing this session right now.